Okay, welcome to question 17. Rightio, this is a ladder leaning against the wall, that's all it is. That's all it is. It's not, I know it's not a ladder, it's a log, but it's the same thing, because I told you it's a smooth wall, alright? Frictionless, so let's have a look at highlighting numbers, alright? 70 kilogram dude, 325 kilogram tree. The trunk is that long, the centre of mass is 2 metres from the base, right? That's the centre of mass down here. The maximum horizontal force is 80% of the vertical force provided by the ground, i.e. the coefficient of friction is 0.8. We did that in the last topic or two, but I gave it to you to help you. All right, on the diagram, show is labelled arrows. Labelled arrows, right, here we go. This one here, now with a free body diagram, we draw arrows going towards the object, or at least in, so you're not going away from the object. So, that is the normal reaction force from what is essentially an icy cliff, right? It's got no potential to give up and down force. Now the bottom has though, and as I do with my class at least, I always break up the reaction force into horizontal and vertical components. And that's what engineers do, and I want to know the vertical component pretty soon, because 80% of whatever that is going to be the maximum force of friction, i.e. Rx, right? The biggest Rx can be is 80% of Ry, according to the information in the question. Here, that is the weight of the trunk, right? And that is equal to, I'm going to write the figure in now because I've already worked it out, just to make my life easier. And this is the weight of Andrew. I'm drawing it as a smaller vector because he's a bit lighter than the trunk. Weight of Andrew, and his weight is 686 newtons. Be okay if you just drew an arrow with 686 newtons, and on the other one an arrow and 3185 newtons. 4 marks for that being correct. B. Now, I could count on one hand of a sloth. How many fingers does a sloth have? Only 3, I think. So I could, there's not many guys and girls who got this right, okay? I'm sorry, but all I want to do is find Ra, calculate the vertical force. How many forces are acting in the vertical? 3. Ry is up and the 2 weights are down. Not everything's about torques. There are 3 conditions for equilibrium. The sum of the forces in the x must be 0, the sum of the forces in the y must be 0, and the sum of the torques about any point must be 0. This is how easy this was. Sum of the forces in the y direction are equal to 0. This is how you do ladder questions as well, okay? Which means the forces up must be the forces down. The only force up is Ry. The only forces down are the weight of the trunk and the weight of Andrew. All right, 686. Let's write that again, 686. So therefore we have 3,871 newtons. That's part of the answer. And therefore the maximum friction force max must equal that number times 0.8. And my friends, that is 3,097 newtons. That is the biggest force that it can apply. So therefore, you see, as Andrew goes further up this way, as he goes further up that way, guess what? He will start causing a bigger clockwise torque, which will mean the normal reaction force will have to be bigger to try to oppose that, to stop him falling, to keep it in equilibrium. But N, if you look at the forces in the horizontal, there's only 2 forces in the horizontal, Rx and N. So if N has to get bigger to keep it in equilibrium, Rx has to keep matching that, or it will slide. Okay, that's how these ladder questions tend to work. Part C, just about finished. There we go. Ready? Part C. Now, I'm going to put Andrew at the end. A few of you did it kind of weird ways. Do it this way. Just imagine Andrew is at the end, and I'm going to work out what force of friction would be required, compare that to the maximum, and see if the trunk will slip. All right, here we go. If Andrew at end of plank, right? I'm going to take the torques about the base. Y because there are two unknowns at the base. Well, I know one of them now, to be honest, but UTAC talks about the base, and there will only be one unknown in my equation, right? We know the weight of the trunk causing a clockwise torque, yeah? The weight of Andrew causing a clockwise torque, and this normal reaction force is causing an anti-clockwise torque, and they are in equilibrium. Well, we want them to be in equilibrium if he doesn't fall. Here we go. So, what have I got? So we have Andrew's weight, 686. That stays at the end, all 5, right? And it's the sine of the angle between Andrew and the trunk. Now go back to the diagram. It's 25 degrees there, but what I want to know is the angle between the trunk and Andrew, and that'll be 65 degrees. Because it's the complement, 90 take 25. Yep. Likewise, the trunk itself, the tree itself, is 3,185 newtons. Its centre of mass was 2 from the base. We're told that it's not a uniform trunk, and it's certainly its weight is making a 65-degree angle with the radius arm, which is the trunk. And then we have the normal reaction force that would need to be there to keep this whole thing in equilibrium. It's the only force causing this trunk to want to go anti-clockwise. The radius arm is 5 metres long, and the angle between the radius arm and the force of the normal reaction force is 25. That was given in the question. From that, the normal reaction force comes out to be 4,203 newtons. Now, as I said before, for horizontal equilibrium, Rx, right? For horizontal equilibrium, Rx must equal N, right? If some of the forces are equal to 0, so therefore N would have to be 4,203 newtons for this to work. Now, last time I checked, that was bigger than 3,097. So therefore, 1 mark for saying no, no, no. The trunk will slip, and the reason it will slip is because we can't have enough of the we can't have enough friction to counteract N that is required to keep it in equilibrium, if you like. Okay, the trunk will slip. Thank you for listening. Please have a good think about where you lost your marks. I would hate you to lose marks the same way